Our last topic for acids and bases is on something called titrations, and your teacher probably touched on this in honors chemistry, but they don't focus a whole lot on it. We're going to do a lot when we get to our acid-base reactions later on. We'll do a lot with titrations, and we'll definitely do some online simulations for these labs so you can see how to do it. But for today, we're just going to kind of introduce what it is and get used to some of the vocabulary. So first of all, titration is a lab method. It's something that scientists can do in the lab. And the way that they do it is to use a neutralization reaction. So it's going to be an acid-based reaction. And the purpose of it is to determine the molarity, the concentration of something they don't know. So for example, if I go back into the stock room at Wakefield High School and I'm trying to determine, I see a bottle that says it's HCl. Well, I don't know if it's 1 molar HCl, which is perfectly fine to use in a lab with students, or if it's 12 molar HCl, which is super concentrated and would be super dangerous for you to come in contact with. And so I need to know what is the concentration. And so this is a lab method you can use to figure out what the concentration is. Let me just go through it real quick and then I'll talk about the vocabulary words. This is a very rough drawing of what it looks like. You basically have this really tall, skinny burette. That's what that tall thing is called. And you fill it with the thing that you don't know. So notice that I have question mark molarity NaOH. I don't know what the molarity is. In the bottom, you're going to put in a flask the concentration of something you do know. So you have to know one of them. Notice that one is an acid and one is a base. And you also can measure out exactly the volume of acid that you're using, or whichever one you know. And then there's one more thing that you're going to put into that you'll put into here as well, and that is going to be an indicator. A lot of times we use phenolphthalein. You may have heard that from first year chemistry. Phenolphthalein is clear in an acid and it's very bright hot pink in a base. So what happens is when you drop a few drops of that into this flask at the bottom, it's going to be clear because it's an acid. And then what you'll do is you'll turn the little lever on the burette and it'll start to drip base into this solution. So it's going to start to increase the pH of your solution. And as it does it, the indicator will turn color. So initially when you drop that base in there, the indicator will turn it hot pink, but as you swirl it around, the base gets dispersed and you use up the base and you still have more acid than base. So it's still going to be clear. Then you keep on dripping it and it'll get harder and harder for you to swirl the pink away, and eventually the whole thing will remain a bright hot pink. What you are trying to do is to get it to be neutral. So you want to stop the titration when it's a real faint pink, which is when it's neutral. A lot of times it's hard to do because the titration curve changes really fast. So we'll talk about this later too, but a titration curve kind of looks like this in terms of pH. So it starts off a very low pH, and then notice that there's a very small window where it shoots straight up, and so the pH changes really fast. So a lot of times, especially as first year college students, when you're actually doing titrations, you'll see them get that bright hot pink when they're supposed to be getting the faint pink because they just put like one drop too many. But the whole point is that you stop the titration at the point where the moles of acid is going to equal the moles of base. And the way you know to do that is because the indicator will turn color. And at that point, so let's say that this volume went down because we dripped it in there. So now we have a new thing. Now we can figure out the volume of the NaOH. And if we know the volume of NaOH and we know this information about the HCl, notice that we can get moles from the HCl. We can do a mole-to-mole ratio to get it to moles of base. And then we can do moles divided by the volume to get the molarity of the base. So going back up here to the vocabulary, the titrant is the thing that you know the concentration of. So in this example down here, the HCl was our titrant. The analyte is the one that you don't know, so that was the NaOH in ours. Equivalence is the point where you get the moles of acid to equal the moles of base. And a lot of people, that should be an E down here, not a 3. A lot of people have trouble with these two, the equivalence point versus the end point. End point is the time when the indicator turns color. So the color change is involved there. If you do it correctly, the equivalence point and the end point should happen at the same time. But they're not the same definition. Equivalence point has to do with the moles of acid and the moles of base being equal. The end point has to do with the indicator turning color. But the indicator should turn color when the moles of acid equals the moles of base. And then the indicator is the thing that will turn color based on pH. And if you don't put your indicator in, you don't know when to stop the titration. So that's another common mistake you see with first-year college students. They'll forget to put that indicator in the flask because remember it's clear in an acid, so you can't tell if you've put it in there or not. And so as they're doing the titration, it never turns hot pink because they're not, they don't have the indicator in there. So then you have to dump it out and start all over again. We've all done it though, so don't feel bad if it ends up being you in college. So the requirements, just kind of go through these. The AP exam loves to ask you concept questions about labs. So they love to ask you, especially multiple choice questions about things like titrations. So just make sure you read through these. Yeah, you guys can just read through these on your own. I was trying to see, I don't see that I put on here that the equivalence point and the endpoint should match. And we'll talk about indicators at another time. Indicators can turn color at various pHs. They don't always turn color at a pH of 7. So these two should match if you do it correctly. And so for a titration problem, when you're trying to solve it, there are two different ways you can do it. You can use, it's kind of like M1V1 equals M2V2, but you have to use the mole-to-mole ratio from the balanced reaction. For me, it makes more sense just to do a normal fence. So if you look back here at our example, we knew the molarity and the volume of the acid. So from those two, we can get moles of HCl. Then we can set up a fence and do a mole-to-mole ratio to get moles of sodium hydroxide. And we already had the volume from the lab, so then you just do moles over volume. And that's what this second way is showing you. If you have liters of A, you can plug in moles of A over liters of A. This is just the molarity of A that you already knew. Then you can do the mole-to-mole ratio from the reaction. So this is from the balanced reaction. And then put your liters on the bottom because what you want is moles on top and liters on the bottom. So notice that your units will cancel here, your units cancel here, and you end up with moles of B on top and liters of B on the bottom. So what I want you to do is to just look at this question, look at the information in this question, and just decide which way you like to do it better. So either you can use the equation that I have boxed, or you can use a fence. Either way, you should end up with this as your final answer, so you can just check those. And the way that you know it's a titration problem, a lot of times it'll say it's a titration problem in the question, but also a lot of times when they talk about neutralizing, that's another clue that it's going to be a titration problem. And like I said, later on in the semester, we're going to do a lot more with titrations, and we'll actually do an online simulation. And I think once you get to see what's actually going on, it'll make a lot more sense to you as well. So for now, just see if you can do some of these problems. And that's it for today.